This video is all about organising data, and today we're going to talk about how you can take a data set and organise the scale in order to reveal a trend. This is a bell curve. This is a really common thing that we can see in certain types of data, and as you can see, it's called a bell curve because it makes a big bell shape. It makes it really easy for us to see an average when it comes to our data, and it makes a really good visual representation of a middle point when we're collecting information. This is the example we're going to be working with today. The class are trying to measure the height of each student, and the data has been collected in 4 columns here, which is randomly ordered based on how the data came in. There's no order to it, there's no rhyme or reason. The tricky thing about this is it's hard for us to see patterns in the data, so we're going to try and organise it in a way that's going to help us see the relationship between these numbers. So the first thing I've done is I've put it in order from the lowest number at the top to the highest number down the bottom. Now in this case, it's easier for me to see some of the repeated or similar numbers. So it's definitely an improvement from the random columns we had before. The problem with this data is it's not a real representation of scale. There's gaps in between all of the numbers that aren't visible. So we might see 2 numbers like 177 and 180.4 being right next to each other, but we might not recognise the distance that's actually between them. So for me to accurately represent the distance between these 2 numbers, it would have to look something like this. The difference between 177 and 180.4 when using a 1 decimal place system is actually 33 units of difference. That's pretty significant. If there's this much distance between 2 numbers, imagine how much distance there's going to be between all 24 of the numbers I've got. It's not realistic for me to represent my data at this close a scale. So the first lesson when it comes to making decisions about scale is making sure that you don't zoom in too much. So we're back to our original numbers. We've made no progress so far. But what we know is that with 1 decimal point, there's going to be so many different numbers on our scale that we're going to need the longest graph in history in order to map all this data. There needs to be something else we can do. So something I'm going to do to make that easier is I'm actually going to get rid of the decimal point by rounding up. Now you'll find when we're working with information, there's 2 things that we do. One is that we round up, which means looking for the closest possible number, and the other thing we can do is grouping, which is where we might look at numbers within a certain category. In this video, I'm going to be using both techniques at different times. So by rounding up the data, I've managed to eliminate that decimal point, and this should mean I've got less numbers I need to work with if I put it on a number line. Once again, the problem here is that this isn't a true representation of numbers because not only are there a few duplicates in here, but there's also numbers in between some of the data that aren't being represented. Let's see what happens if I create a real representation. Yikes! Look at the size of that. There's a lot of numbers on the page there, and it looks like the scale's gone out of control once again. We can barely read the numbers on our screen, and we certainly wouldn't be able to read it if it was on a page of information. So we're going to have to do something else with scale. Before we move on to that, I want to look at a couple of other tools. One thing you might have noticed in the jump from slide to slide is that in the previous slide I had some double ups of numbers, but now that I've put the numbers from 133 to 180, I'm not showing the duplicate numbers. So I'm going to need a different way to show it. And the way I'm going to do that is by using a tally. When we use a tally, we can see relationships or double ups in numbers without having to list the numbers more than one time. It makes the information easier to read and it's much easier to organise. The problem with this tally is it's so spread out and the numbers are so small, I can't really see a clear relationship between a lot of the numbers. For the purpose of this exercise, I've got rid of all of those numbers that were in between, so at least we can read the numbers now. The problem is it's not a true representation of the data because there's numbers in between these numbers that aren't being shown. Even though it's not an accurate representation, I'm going to take this opportunity to see if I can find a trend. Now a trend in this case is a general change in variable, and the particular trend that we're looking for is a bell curve. If I use my red highlighter here, you can see that I've followed where there's been duplicates of numbers to see if I can find a bell curve. But while we can see a couple of loops in different parts, we can't see a clear bell curve yet. So this data set isn't working for us. So if I can't see a trend in my data, I need to adjust the scale. So what I'm doing in this case to adjust the scale is I'm grouping the numbers. You can see along the side in the green that I'm grouping numbers in variables of 5, between 130 to 134, 135 to 139, etc. What you'll notice in this case is I've no longer got any gaps in my numbers like I had before, and it means that I've covered every number from 130 to 184. To make it easier to see, I've removed the spaces that were in between, and now I'm going to use my tally tool, and let's look at the difference. If I use my red highlighter, I can see it's got significantly lumpier, and I can see that it's moved up right at the beginning, dipped down again, and then moved up. It almost looks like an M shape, but I still don't have my bell curve, and that's the trend of data that I'm trying to achieve in this case. So what do I do if I can't see a clear trend? I adjust the scale. I've taken the same approach from last time but moved a little bit quicker. This time I've moved from representations of 5 to representations of 10. So I'm going to use the same process and I'm going to add my tally. Oh, now we're looking at something. This is the closest I've got so far to representing my bell curve. If I use my line tool for this representation, I've got a much closer representation of the bell curve trend because I start in a lower end, I move up to a clear higher point, and then I slowly make my way down. It's not perfect, but it's a better representation of the trend I'm looking for than the previous data set. I know what you're thinking. This guy moved from units of 5 to units of 10 and his data trends got better and better. So why don't we just keep moving along the line? Surely we're going to get an increased result. Well, let's have a look at this. So I've moved from units of 10 to units of 20 in the purple. Now you can see from this data that I've still got a pretty good clear pattern moving from the highest to the lowest. But there's a problem. I've lost my bell curve. I no longer have that lower end of my data. So by adjusting my scale too much, I lose the intended trend that I was trying to find. This goes to show that it's really important when you're dealing with data samples to adjust to give you the best representation of that data to suit the trends that you're looking for. Different trends suit different types of data. Once I've decided on the best representation, I can then look at creative ways to show it. This bar graph, for example, represents the movement of data across a class of students, and it's represented in a way that's clear, easy to read, and demonstrates a really clear trend.